Hi, welcome to my channel about embedded systems, fischtechnik and robotics. If you're new to my channel or haven't subscribed yet, please subscribe via the thumbnail in the bottom right corner. As you can see, the focus of this video is my hydraulic set made of fischtechnik, with on the right hand side the manually operated part, and here is the automated operated part, and it is automated by means of Python. This rubber band is driven by this light beam, which is interrupted by a piston. Last time, and let me focus the camera right here, I had to refill the pistons in order to get nice results. And one thing that is now very clear to see is that the number of air bubbles, air sockets, air pockets is minimal, if there are any. And one main reason is that condensation has gone, since the temperatures are much lower now. It's autumn, going towards winter, and I can see the difference. Big question is, of course, by absence of air, will the operation of everything be much better then? So let's take a look and see how that ends up. First thing, with this piston locked, this piston free to move, and software not running. So this one is not running, so this fan will not start running, this press being switched or not. So okay, this shows, and let me do it like this, that there actually is a little bit too much air inside, way too much, but on the other hand there's 1, 2, 3 pistons inside. So this gives a big air pocket, unfortunately, and then you can see that this one doesn't move at all. So I have to use manual force to get it done. That also means that I have to refill anyway, because now there's a very big air pocket in here, unfortunately. That said, will that solve this problem? I'm not quite sure, but refill first. And I refilled with these two pistons both locked in the most downward position. So all water and air pushed or pressed out of it. Fully filled with air, some very tiny air pockets. But let's see anyway how this works out. Okay. This shows some air here, and this has at least some better response, but I need to refill this with some more water. Apparently, despite the colder weather and less condensation, there's too much air in it. And this time I had, with two pistons, the little bit weird situation that I could not push this piston entirely to the end, and not even when I took this out. So with the hose removed here, there came a lot of air and some water out of the hose. So now I'm very curious what will happen. Okay, that's not what I had hoped for. Not at all, because I want this to happen. So something is still not quite the way I had in mind. How can I improve this? Maybe by lifting these things a little bit. I have to try, because this is no good. This is good, but when I do this and I press again, I expect this one to go up again. Not happening. Not nice. And with some observation, I noticed that this one, this support is, or the from here the back support, that is front support and back support, and the back support has not the same, well, let's say support on the desk as this one. So I'm going to put this one under that support, and hopefully that solves at least a little bit of the problem. So with that support added, let's give it another try. And oh, now I know what's going wrong, because this one is has to be locked. Although it has some improvement, there's still a problem. It is still flexible. Well, fischertechnik is flexible in itself, so I can't do much about that one. But this part is more robust than that one, so I may have to add something in between here. And that is something in between here. And for the rest, what can I do? If I do it manually, it works out. But the point is, I want to do it like this, and that doesn't work out still. Remaining a problem. And observation leads to two more things. First, there's an air pocket here. But another thing, something that I mentioned earlier, flexibility. If I press this down, the air pocket is one course, but mind this one. It's too flexible. It is lifted off the desk, and that flexibility makes that this is not reaching the switch, and that's a problem. But how to solve it? Because you well, you want some flexibility, but in this case rigidity is better. How to accomplish that? That's a big question, but I'm not sure right now. Anyway, let me test the rest, and for that I need some software. So I'm going to switch to screencast. Right, so screencast with obviously Python code, terminal to run the code in, and the camera. And to come back to the rigidity, what I could do is make a construction that spans from here to the support which ends here to the support which ends here. So since this is already a spanning construction, as I call it, maybe a completely wrong name, but that may improve things. However, first I'm going to move the camera a little bit so I hope everything is visible. And that means this is visible and that is visible. And that is not what I would like. So, easiest part is to do it like this and continue. Well, that's at least something that seems to work. And mind the part here, because that part that starts this rubber band. Not right now, obviously. And it should start. Oh, I noticed something has gone wrong right here, because this lamp should be there. See, now the lamp shines into the receiver, which makes this one run, obviously. So that's one thing. Now for the manual part, obviously this is supposed to happen, which it doesn't if I do it the way I did it before. So only partly, and now it is supposed to get back and it doesn't. So now it runs, very small push back, and then we have the problem. There is, I can pull it back right there, but again some air pocket, as you can see right here, is preventing proper operation, at least from here. So it seems that I do need that construction and see whatever happens then. And without even having reconstructed or constructed this part, I noticed that the construction here was different from the other support. On the other support it was this block with two space fillers, and it was this one which is completely different in height. So now they are the same, but it doesn't change anything. This is nice, this isn't, and this flexibility, this is less flexible, and this is also very flexible. So I really see a necessity to connect these things, these supports. Do I have enough material? I do hope so. Well, the rigidity has increased somewhat by this addition, but the result isn't what I had hoped for. So this is working, and let me put this entirely to its end. Okay, and once again I had to lock this one. So once more, this is alright, but notice the air socket in here, very big. It has improved, but not as much as I would like. Not in the least. Alright, and go up, and it simply doesn't go entirely up. I have to manually operate, and then that happens. So, some improvement, but not fully. Unfortunately. What to do about it? Well, right now, not much. One thing that keeps occurring is that I have to keep refilling because condense, evaporation, you name it, flexibility of fischertechnik, and well, that's good because all material is in itself flexible. If it wouldn't be, even houses wouldn't keep standing. Even concrete is flexible. So, if that's not a solution, what is? Thanks for watching. If you like this video, please do subscribe to my channel. Give the video a thumbs up, click the bell for notification, and please leave a comment or suggestion. You can also follow me via Twitter and Instagram, and you can support via PayPal, Ko-fi, and by becoming a patron for as little as €2 or $2 a month. This is going to be continued. Please take a look at my website for more interesting fischertechnik projects, also embedded systems and robotics, obviously. For now, stay safe, have a great day, take care, bye.